Hello, everyone. My name is Abdulkabir Musa. I'm a software engineer and founder of Briefly. So today we're going to be looking into um, a concept that is divine, like it's shaping how we use AI and actually deals with the privacy of AI. So like how about difference between private, how we use AI on the edge of privacy first, and the one that's like the general differentiating it from the general one. So we just have a topic here which says the small model revolution, like the edge of AI and its privacy. So we'll be looking very, very deep into small models because most people doesn't talk much about small models. We usually talk or heard a lot about frontier level model, which are those large language models that are very powerful and has tons of parameters, so like trillions of parameters. But most people are not looking or talking much about these small models, which is much more powerful. It's also powerful, and it is mainly used for a specific case. So that is the main, or that's the focus of this session, and we'll be diving deep and like we'll be diving deep into these concepts so that we can understand how it is revolutionizing some certain tasks that these small models are being built for, and how it's giving user their private, like it is securing user privacy. So now let's first define the problem, because there is no solution without a specific problem. When there is a problem, then we try to solve it. So that's how natural things work. So the first thing is that we didn't realize that we've been chasing the wrong metric for a long time. Because when you look at most of these frontier level model, like Claude level model, GPT by OpenAI, Mistral, DeepSeek, many other frontier level models. So the thing they didn't say, or most users didn't pay attention to, is that most of these models use 10 times more compute than needed for a specific task. Like like for instance now, you want to ask AI, help me to solve these arithmetic operations, like help me to do this small task, piece of task. So it will, the task, like the compute that this single task or this single question will consume, like the compute it will consume, which is some calculations it will do on under the ground, like the job. So it's much more complex than we might think of. So which means that this frontier level model, they use very huge or large amounts of compute, more than the specific task at hand. So which is kind of like, which can be really, like, it doesn't really make sense, because when you ask something to do, like do the specific task, right, you expect that it should only do what you ask it. But in the sense of AI, there is a lot of ways it calculates things, compare different patterns so in order to give you the right answer. So it does a lot of calculations and computing stuff, so as to provide you with the correct answers, which means that compute happens a lot. Like it takes it a lot of compute happen under the hood. And the second thing is that training this frontier level model, like Claude, all these Claude, Sonnet, Opus, GPT-5, all these different models level that has been deployed out there. So it takes around roughly $100 million to deploy this to the end user, so that billions or millions of users can started using these models. So the costs, those costs are very, very, like, they are sensitive. The cost is very high. It's very high. That's why most of these AI companies, they are trying to limit the amount of free access for users, because they are spending more on training and deploying most of these models. So it means that it's definitely cost more than this, but it's just the limited one. Like this is just like the minimum. So, and also data science, you definitely know that all our data are being stored on their server. Like whether it's your username, any of your data, your charts, your anything you communicated with the AI, everything entirely 100%, they are being stored on the on their server. So which means that none of your information is safe, and they can literally use it to train their they can usually use it to train the model, and which means that the data that is being used to train the model can easily be exposed to another user. So these three, they are just few problems. Are just few problems of most of these frontier level models. So when we look into this deeply, we know that we should be able to, and we should be able to like make a concise statement that bigger model are impressive. They are really impressive because when you look into it, a single model, like all these bigger model, like single model, frontier level model, they can do multitask. Like they can do arithmetic, they can do mathematical stuff, they can also do statistics, they can do normal natural, like your normal English, many other things we are using them for. They can do complex and different kind of things. But being impressive is really not equal to the right deployment. Like it is not really equal to the right thing for the task, right? So you can do mathematics, right? A model that can do many things doesn't mean that it has expertise, like full expertise in the mathematical stuff. So that's one of the things we should also be looking into. So now let's quickly move into the definition. What is this small model? A lot of people will feel like small model, large, small model, frontier level model. Let's just quickly differentiate and give some few definitions about what is this small model to be precise. So now, small models are typically models roughly around 1 billion parameters to 7 billion parameters. It means that when you look, okay, let me just quickly give a different explanation this way. Most of these frontier level model, like all these GBT model, Claude, Mistral, DeepSeek, all these frontier level model, they are like their parameters are even around trillions of parameters. Trillions, let me just say trillions. So small models are very simple, like their data sets are very small. Their data sets are very small, which means that they did not even require GPU to run. So they didn't require they can easily run on a local system like your laptop, your phone, or your embedded devices. So it is they can run all these small models, they can literally run there safely without slowing the application down. So, and second thing is that they are fine-tuned, not general purpose. Like fine-tuned in this and in this case is that most people doesn't might the meaning might differentiate based on like the context of fine-tune might be different based on what case you are using it for. But the fine-tune in this case is that they are built for a specific task, which means that a small model within 1 billion to 7 billion parameters, it means that all the tasks or anything, any question, anything you can, any solutions it can solve for you, it's based on a specific task. Like it can only do mathematics, it can't do anything apart from mathematical stuff. It can only do coding. It cannot do anything apart from coding. So that is the kind of small model. It means that this specific model is built for this kind of task. You can use it for something else. So example of it is medical notes. So there are some small models that was deployed for medical, like it only generates medical notes, some models for code review only, which cannot do anything apart from that. And some models are built specifically for customer support, which means they can't do everything. They are only built and deployed for a specific task, like a specific purpose. So, and one more thing about this small model is that they are on device, like they are built on devices, not like you can call them like you can use them on API call, right? So they are usually tightened or built or configured with your hardware. So it means that your data usually stays on your device, on the device you are using, whether it's a mobile phone, whether it's a laptop, or any kind of device you are using. So it means that these small modules are tightly built in and they are tightly integrated into your devices. You can't use them externally since they are not for general purpose tasks. So there's no API call. It eradicates API call. It also eradicates cloud dependency. So This one of these just a few ways you can understand what is small modules to be precise. So let's just quickly list some of notable small modules, like those ones that are very popular. So first one on the list here is the Pi 3 Mini by Microsoft. This is roughly around 3.8 billion parameters. So you can use it on your mobile and edge reasoning. So we also have this Gemma 2B, which is 2 billion parameters, which was developed by Google, and it's an AI assistant like the one Google used on Gemini on mobile. So which is built in, like you can ask it to do anything, navigate within your mobile phone, and do search, do web search, and many other few things. So those modules are built in. They are fully integrated into your devices. So we also have Mistral 7 billion parameters, 7B, which is around 7 billion parameters. So it was developed by Mistral AI. So it did just an instruction tune task. So you can use it to navigate some instructions. So we also have Llama 3.2, which is roughly around billion parameters. It was developed by Meta. So this is just list of some. We have several small models, but this is just most popular one and just little bit of them. So that is this is just a little glance into how what is small model and how it actually works, an example of it. So now let's look into the cases of small models, how it works, like what is the benefits, and let's just quickly look into that. So now let's look into why, because when something have advantages, it will definitely also have disadvantages. Same thing for frontier level model, and same thing for also small models. But today we are looking into much. Let's just quickly look much into the advantages of small models. So the first advantages is that it is privacy first, which many users, like tons of users, actually want, because in most cases we want our data or our informations to be private and safe, right? We want it to be safe. So that is the first benefit of small model. It is privacy first. It means that since we've already declared earlier that small models are tightly integrated into your hardware, like they are integrated into your, they are not called, they are not used by an external API call or a cloud infrastructure. So they are on their own device used. So it means that anything or any interaction you have with these modules, all the data and all the information stays on your device. Nothing leaves your device. So that gives user peace of mind first. So there is no server log, there's no third-party exposure. The only credible answer to this is we have all these law of GDPR and many other things, which contribute to the privacy first of these small modules. So we also have the second one is the real-time speed. So there's nothing like, oh, there's no network where I am, I can't use these model. That is totally wrong, because these devices, they are on device. So it means that whether there is network or there's no network, so far as there's power on your mobile phone, on your device, you can literally use it. It is safe. It does not require network. You just have to just use it, and the inference is very low, around 100 milliseconds locally, compared to an external API call, especially if there's even more latency. So that calling an external API call will be roughly around 500 milliseconds to 2 seconds, even more, if there's more or huge latency. So it's very safe, and also introduce speed. It's because when something is already on your device and you want to interact with it, that is much more, it's very seamless. Like, there's no delay. So it's better, it's much more better, it's much more better in speed than an external API or cloud infrastructure based models. So which means that there's like critical for voice. Like, for instance, now if assuming now that you are recording, you are recording your voice, and you need to send this piece of recorded media to server, for server to process it, then to generate back response. That's, if we look into the difference, like the speed and latency between those process, it will take much time when it's an external API call. But when you look into, if it is an on device, everything is being done locally, and there's no gap. Like it's just a piece of code running sequentially after each other. So it's much more faster and better than an external API call. So same thing for on-device search. If you are searching any kind of roughly anything within your device, so it's much more faster with that. So we also have real-time features. Like we have this feature Google integrated. I think I think Google Pixel, I don't know, many other software or all these device software also integrate, but I think I should just use Google Pixel as an example. Whenever, like something like whenever you take a picture, you can just highlight a specific place, like a specific section in that picture, and ask the AI to remove that piece of thing, or it will generate something there. So this kind of thing this kind of AI doesn't require external API call, and you don't need to have your mobile data or Wi-Fi connected. Everything is done locally. So the kind of model that is capable, like that is required to perform such kind of task is small model, and they are fully integrated into this hardware. So that's why they introduced such kind of capabilities. It means that most of these people using these features, they didn't know that there's something called small models on their mobile phone. So that the small module that was fully integrated into the hardware, into the device hardware, that's what give its capability of handling such kind of complicated stuff. So third thing is that we have radical cost efficiency. So nowadays, AI companies are starting to increase like they are decreasing the amount of credit for free users using their AI tool, and they are increasing the cost of paid users, like people paying $10 monthly. Previously, they are now paying around $15 monthly, because the more AI keep advancing, or models keep becoming much more powerful, the more cost and computing it will be required. So it means that this will also bounce back on their users. Like the cost will also rise based on recent blog I read about GitHub Copilot increasing their price and other stuff. So this is also one of the complicated stuff of these frontier level models. So comparing these kind of situations with on-device or small modules require zero cost because it is built into your device. So you really don't need any cost to use it. It is completely free. There's nothing like monthly payment or something. No. So it was fully like it was tightly integrated into your device. You don't really need monthly payment or something. So, and this module, since we've already said, these all these tasks runs on modules roughly around 1 to 7 billion parameters. So, and the cost is very, it's zero. So comparing these with external or frontier level module, which you have to send an API calls to, which per API call they might be charging you $0.03 or something around it. It has increased nowadays, or recently it has increased. So per API call, whether the response or generated content is correct or not, it is bad or right or something, they didn't care. Any API call, they charge for it. Any API call, it is being charged for. So comparing that with this, you have to spend much on frontier level model more than small model. So when we look into this, and if we look at companies sending billions or millions of queries to most of these external models, which through the API call, it means that they have a lot to pay every day. Like they have tons of dollars, like thousands of dollars to pay every day. Comparing that with on-device model, which costs zero. No matter even though if you use it billions of times in a day. So this is also a big and huge benefit to between small models and frontier level model. So the last one on the list here is offline reliability. So whether you are working on hospital, whether it is playing remote area somewhere with very high amount of latency or low bandwidth, anyway, this on-device model works perfectly since it doesn't require network or anything. It's built into your device. So comparing these with these external API, these model, extra frontier level model, where you have to send an API call. So it means that if there is no network, we can't gain access to it. So the difference are very, very huge, and we've seen a lot of benefit, and how small model is much more better than most of these frontier level model. So now let's quickly look into the privacy and of small model, which is the killer of it all. So now the big issue we have nowadays is the cloud AI privacy problem, because whenever most of these big companies, like, they gather your informations, your datas from using their store, from using their platform or any other thing. So most of the data they gather, they store it in their server, and you can't really say what exactly they are using it for, right? You can't really say, because they store it in their cloud server. They are the ones securing it. They can gain access to most of this data, analyze it, do a lot of different stuff. So most users doesn't really know what they're actually doing with it, which is really, really scary. So now let's quickly look into the cloud AI risk and the edge AI solution. So first thing on the list is that every query log on vendor server. Like, for instance, now you are using Claude. You're using Claude to chat, do some few stuff. Let me just use Claude as an example. You are using Claude.com or Claude.ai. So we are using their platform to do some few things, whether some research, assessment, or some interactions, some email drafting, and a few other things. So every message and interactions you have with this AI, they log informations and query about these messages on their server, which means that all the details of your interactions daily, Claude is tracking everything, and they're actually knowing what specifically you are communicating with their AI. So, which is really scary, because it's your privacy, right? So, yeah, if we have to be clear about it, it means that it is only privacy to us, right? It's not privacy to the cloud infrastructure or the cloud provider or the AI providers. So, which is really not good. And it's and when you look into it deeply, it's really not, it's really bad in short. So the second thing here is healthcare and legal data exposure. So a lot of medical companies or healthcare facilities or healthcare solutions. So they have a lot of informations, like some legal informations, users information they didn't want to expose to anyone, or external company, or external anyone, in short. So most of these, anytime you have communications with all these AI, or they use the API to do some few things, passing the company information, send it through this AI. Everything is being stored on their server, on the AI providers. Cloud, let's just use Cloud, for instance. It's being stored on their server. They can use it to retrain their model and do many other few things. So in this case, it means that healthcare data informations it won't be safe anymore. And whether it is law or legal data informations, everything is completely at risk. So this is one of this is just the second reason why cloud AI is very, very risky. Like, the cloud infrastructure of AI platform is completely very risky. So the third on the list is vendor policy and changes that affect your data. Anytime they can change their privacy policy rules. So whenever they change it, they can literally change it to what will benefit the company, and you won't be able to file a lawsuit against them. So which is very scary. They might change their privacy and policy anytime that they will be consuming your informations, which Meta did recently about your private chats to train their models and many other things. So this is something very, very scary, and it's their companies, and whenever they change their privacy, or you've adapted yourself to using their platform, whenever they change their privacy, it means that privacy and policy, all the informations you have on their platform, they can easily gain access to it and use it on a secure, like, they can easily use it on a legal law, that it's something they can use freely. So, which is something we also need to look into. So fourth thing on the list here is jurisdiction and compliance complexity. We have different jurisdictions have their own personal law. The law in the EU is different from the one in Africa as well. The one in Ghana is different from the one in Nigeria, China. Everything is different, and how each companies manages their laws of users' informations are completely different. So the jurisdiction also affects how most of these big companies access users' private data and make use of them. So the last thing on the cloud AI risk is breach of data, which is equal to breach of all queries. So whenever they breach their users' informations, it means that nobody on their platform, all the data of the users on their platform, they can completely use it for free. So which is or let me just put it this way: whenever an external provider or an external person gain access to user informations, so it means that all the user information within the company is being exposed to an external person. So which is something we also need to be very, very scary of. So now you see a lot of benefits of how edge AI solutions, how edge AI brings solutions to such kind of cloud AI risk. So the first thing is that these small models, since the data doesn't leave your device, it means that there's no external access. Someone is not gaining access to it. The data only stays on your device. So second thing is that no retention, no log, and no third party. So everything is secure on your device. You have no logs, you are not logging anything anywhere. It's only being used on your device. So third thing is that works in an environment where there is issue, where there is no internet, there's high latency, or it's a rural or somewhere that has no network connectivity. So it works there. It doesn't require network connectivity, and this also provides high compliance to the GDPR architecture. So which means that user can have full they really have full belief in such kind of product. So user trust become a product feature, because whenever we are promised, or there is a product that promised privacy first, and we confirm that the device doesn't leave user's device, like you are the one that own your data. The data doesn't leave your device. So user trusts such kind of products far more than far more than their data that is in a remote server. So this is just a little bit killer into how privacy first work in cloud AI privacy and the edge AI solutions. So now let's quickly look into some few numbers and just quickly highlight something. So the first thing, we'll be talking about the efficiency gap in Instagram. So the thing is that when you look into an API call, we have 10 to 100 milliseconds sometimes when you are calling an external API call. But comparing these, like the difference is very huge. Like comparing 1 to 10, comparing 10 to 100, you see there's a huge gap between the two. So comparing this with an on-device API, so it's very, 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 very huge. The difference and the gap between it's very, very huge. So whether we are talking about latency or many, many other things. So we also have 99% cost reduction. When you look into small modules doesn't require, you didn't have to pay anybody. Like it's free to use, it's on your mobile, it's on your device. So it means that you are not paying anything. You are not paying anything. So that's another big benefit and advantage of using small modules. So comparing this with cloud API call, whereby you are per each API call you are paying roughly around 0.03 per API call. You have to estimate billions or millions, thousands of API call per day. So, but in the case of small module, you don't, whether you use it millions or billions of times in a day, you didn't have to pay anybody. It's completely free and it has zero cost. So another thing about small module is that its maximum parameter is roughly around 7 billion parameters, so that it won't affect the performance of your device. We need to consider when we are talking about um um design into like data intensive and something like that. We also need to consider how reliable the module can perform well on the device without crashing the existing system. So 7 billion parameter is a lot, and it's good for a specific for a module that only perform a specific task. So something like GPT-3, so which if we have something like GPT-3 that has a domain of task, like it has a domain of solving math problem or something like that, so we can fine tune it properly and it will be very okay. Then we can deploy it on on a device, so which we can easily use. So this is something, comparing this with trillions of parameters of frontier level model. So the gap is very, very huge, but the benefit is there. So, and last thing here is 0 milliseconds of latency. Comparing this with online of or on of comparing this with cloud latency. So it's very huge. The gap is very huge. Where you have zero latency, and comparing it with whenever you send an API call, you have around 100 milliseconds of latency. So offline is always faster than a remote API call. So the difference and efficiency is right there. So one thing we need to note here is that efficiency is not in compromise. For real deployment, it's the competitive advantages. So we need to know that, so as to determine or know the right choice for or the right best choice for us. So now let's quickly look into real world use cases. So now let's quickly, first thing on the list here is the healthcare. Many healthcare are already using on-device modules, like all the on-device small modules for clinical note summarization, patient data, whereby patient data never leaves your hospital network. So it means that your company informations or company data or healthcare center data are completely safe. So second thing is that we have mobile apps. Apple already implemented intelligence, whereby I think it's their iOS 16 point something. So they implement an intelligence of Siri, like advanced implementations for Siri, whereby it's getting more smarter and more efficient to use across their software. So we also have Pixel AI feature, which Google integrated into their mobile phone. So these features allow for real-time on-device use, and there's no upload required. Everything, it knows, like it can locate all most of these informations it's dealing with. So it's very easier for most of these models to process everything within the device and produce outputs without requiring network connectivity, which is a very, very huge advantage. So we also have manufacturing companies. They are also using AI for quality control on their factory machines. So these are another benefits. We also have emerging markets, like we have AI powered tools optimized for low bandwidth, low cost device across Africa and Southeast Asians. We also have legal and finance, which they are using AI to review most of their contract documents. They're using it to review it, which is much more faster, because most of these legal companies or finance, they have tons of document they have to review, which they need to review. So in most cases, it actually takes more time, like few weeks or some couple of months. So with AI, this can speed up the amount of time they need to summarize or review most of these things. Like it can reduce a month reviewing document to around roughly a week, which is much more better, or few days. So we can see that the benefits and the advantages is very, very huge. The benefits is very, very huge there. So it's something that we can see. So we also have automotive solutions. Most car we have Tesla car, they are implementing an AI assistance car, a self-driving car, which whereby you just need to put in your location. The motor, your car can drive itself and connect with different signals, locate, like the models can determine a lot for itself. This kind of model is not an external one. In most cases, they are built into the car, so that without, if there is any lose in network connectivity to the direct center, it can easily navigate its end and find its way around. So we see a very huge benefit, and much more advanced technologies are being emerged. So this is a very, very big advantages for these. Most of the things we listed here, they are being powered by small models, which introduce a lot of benefit to the advancement of technologies. So now let's quickly look into how big we should let's quickly look into the statement which most people talk about, like most people say about how big is your model, comparing it with how fit for a specific purpose. So most people love talking about how much is how many parameters is this model, how complex it is, and many other few things. So, but the main things people are not focusing on, or they are not asking, is that does this model fit for a specific purpose? Can it do this kind of task successfully without needing assistance? Can it solve this, like a specific task? We need to start asking such kind of question. So, like, let's quickly look into the hype mindset. So most people usually say, especially people in the technical space, that more parameters equal better. Like if we have trillions of parameters, it's much more better than few parameters. So most people also say when you have a single model that can do everything, it's much more better. It means that you can reduce cost. People say that you can reduce cost. You don't have to be you don't have to be switching between multiple models for a specific task. So, and some people also said that cloud first is better for, and privacy later. We can start with cloud first, then we can later start thinking about privacy. So, and some people also feel like whenever we compare this model on benchmarks, either, but we can divide which one is much better and which one has the highest value. So, and some user accept latency, like if the latency is 1 second, if it is 3 seconds, if it is 4 seconds, I really don't care. I really don't care. So, but most of these hype isn't good enough when it comes to real world scenario, and they are actually better because they are actually better. It also have its own advantages, but I believe the disadvantages is much more better when you look on long term run. It's much more complex than we might think of. So let's look into the efficiency mindset. So the first is that right size for a task, even though if the parameter is around 1 billion parameters, but it is better and can do a specific task efficiently. Like it's fine-tuned for a specific task and it can do it efficiently without increasing compute cost. And so it is better we use such kind of model than a model that is trillions of parameters but cannot do what a billion of parameter is doing. And that's we need to look at such kind of gap. So the second thing is that specialized always beats general. Okay, let's give a simple example here. When you program, like you introduce yourself as a full stack engineer, you believe that you can do everything on the full stack side, like on the front end or the back end, anything around the space, you can actually do it. It's really cool. It means that you have general purpose idea on both sides. But whenever someone calls themselves as a front end engineer, like that is where they specialize. It means that they have more in depth on this field, on this concept, on this field, more than you that have a full stack knowledge. And someone who specialized on backend always have far more experience and good at backend, far more than someone in full stack. Someone in full stack is also good, They can bridge the gap between the front end and back end. But someone that specializes on a specific field, they are much more good, and they are determined to go more far than someone that is trying to grab here, grab there, and here and there. So that is why we said specialized beats generalized. So when you specialize on this on a field, you are much more good in that field than anyone else. So which is something that has been in existence so far. Like I believe everyone should know this. It's the best like the best concept with all the best ideology we need to be using. So second thing is that privacy by architecture. Most people always feel, let me just quickly build this product and start caring about privacy later, or later start caring about architecture. So in most cases, it's better you start with privacy in mind. When you start with privacy, it means that when whatever you are layering on it, they will keep using the existing architecture you've already defined. It's much more harder to build something first, then now later come back and start working on the privacy, or building something you're supposed to have defined or introduced when building the architecture, like when building the foundation. Then you are now later trying to introduce them later. So which is really, really bad and can affect the product in general, right? So we need to that's also one of the key benefits of building a privacy first architecture. So second to the last here on the list is real world deployment defines value. When something shows a better performance in real world, it has much more value than benchmark. Like the kind of way when we have a small model that is solving big problem for people, thousands, millions, billions of people, and we have frontier level model around roughly trillions of model that cannot even solve that same task for people efficiently. So people will easily divert to the small one because they know that this can solve this specific task. Whenever I need another task that it can solve, I will go to something else that can solve it. So people rely and believe in such kind of thing. So that's how real world works. So we need to in real world we need to believe, or we need to shape things in with value, not with leaderboard or something else. So and the last here on the list is user device instance, like user the latency information. So people usually feel like if there is latency, I didn't care so far as it's working. So in most cases, we really need to care. Not even in most cases, we really need to care about latency. First reason about it is that whenever you are building something very complex and they are intertwined together, like this output depends on this output depends on this, you go and so on and so forth. It means that if the first isn't completed, the second won't proceed, right? Assuming now that there is now very huge, like 2 seconds or 3 seconds of latency between each, it means that for you to move from first to second, it will take up to 2 seconds. From it will take up to 4 seconds, right? From second to third, it will take up to 6 seconds, and so on and so forth. So when you look into this to real world scenario, it means that you might have to wait sometimes around roughly 10 minutes, 20 minutes, for 30 minutes, 40 minutes, or an hour for a specific task to complete. Comparing that with zero latency, you really didn't care about latency, like you didn't even need to care about it because it's zero latency, it's very, very fast and privacy. So you start a task and it's immediately completed. So that's something that brings happiness to users. So we really need to have the mindset of latency, very low latency. There will always be latency. You can't completely eradicate latency when it comes to an external API call, right? You can't really eradicate it, but you really need to have low latency. But despite that, you can never compare that with an on-device model, which have zero latency, which is very, very huge advantage. It's a very huge advantage. So that's just the different mindsets we have here about how big. We should stop asking about how big. Instead, we should now start asking or talking about, does this model fit for the specific purpose or the task at hand? Okay, so now let's round up the session with a specific quote I have here. So the quote says, the most powerful AI isn't one with the most parameters. It's the one that's running on your device right now. If you have a device that has built-in on-device model, right? So it's literally about these modern devices. So if you have one, it definitely means that you have a powerful toolkit right in your device. So because you can use them efficiently based on all the characteristics we've said so far. So they have a very huge benefit and billions of advantages. So we need to kindly look into this direction instead of the opposite side. So efficiency is a feature, not a compromise, and privacy only solved on device. When you have something on your device, privacy, there's nothing like external server sending any data to external server. That's your privacy. And how can we solve a privacy solution is for you to have such kind of to have your data being stored on your device. So third thing on the list here is small plus specialized. When something is very small but is specialized in a specific task and can do it perfectly, that is much more better and good. It is greater or better than large plus general, right? So thank you once again. My name once again is Abdulkabir Musa. I'm a software engineer and a founder of Breathe. So, all right, thank you guys.